Yes, welcome to this economics. This is econometrics. Today we are going to look on how we can solve different hypothesis problems so as we can capture the materials and how we can apply the knowledge of hypothesis testing in solving different economic phenomena. Now, for example, let's consider the following example. It is claimed that a vacuum cleaner uses an average of 46 kWh per year. Now, if a random sample of 12 homes included in a planning study indicate that vacuum cleaner use an average of 42 kWh per year with a standard deviation of 11.9 kWh, does this suggest that at the 0.05 level of significance that the vacuum cleaners use, or an average less than 46 kWh annually? Now assume the population of kWh to be normal. So it is claimed that a vacuum cleaner uses an average of 46 kWh per year. If a random sample of 12 homes included in a planned study indicate that the vacuum cleaner uses an average of 42 kWh per year with a standard deviation of 11.9 kWh, does this suggest that at the 0.05 level of significance that the vacuum cleaner is used, or the average or less than 46 kWh annually? Now assume the population of kWh to be normal. Now solution for this scenario we need to write down the data given, whereby we have the number of observation which is equal to 12. We have the population standard deviation is equal to 11.9 kWh. We have level of significance is 0.05. We have the population 46 km per h. We have also sample mean is equal to 42. So under the procedure for hypothesis testing, we are going to tackle this question as follows. The step number 1, we set out the null and alternative hypothesis, whereby we'll be having the H naught such that the sample population is equal to 46, and we have H1 that sample population is less than 46. Since our scenario is based on the one side which is less than, that's why we demonstrate the fact with a sign of less 1 is equal to 46. Now step 2, we determine the level of significance. The level of significance already we have been given is 0.05. 0.05. The step number 3, we apply the suitable test statistics that will be favorable on tackling our question, on tackling our scenario. So the test that is most favorable here, it will be the t-test, since the number of observation we have is less than 30. And the standard deviation, the population standard deviation is unknown. Now for such case, now we go to the step number 4, where we apply the decision rule. We choose out in where now we can accept or reject a null hypothesis. We apply the decision rule by drafting out this situation over here. Let's consider this this drawing over here. We have the acceptance region on the right hand side, and we have also the rejected region on the left hand side. Now suppose now we cut up our graph in 2 parts, and we have the acceptance region, as I told you. We have also rejected region. The level of significance is 0.05. And when we divide the graph in 2 parts, 95% of level of significance, when we divide by the 0.05, we obtain the 2 parts number of 0.47 in both sides. Now the degree of freedom we have is the number of observation minus 1. So we take out number of observation, whereby we take 12. We have taken 12 minus 1, which will be equals to 11. That's the degree of freedom. Now we lead the degree of freedom 0.05, comma 11, which is the degree of freedom of 11, to the t-test graph, so as you can observe out the answer. So the answer will be negative 17796. So step number 5, we correct the sample data, whereby we correct our data where we have number of observation is equal to 12, that is given. We have also the sample standard deviation is equal to 11.9. We have level of significance 0.05. We have also the population standard deviation is 46. The step number 6, now we apply out. From our corrected data, now we solve out our what is known as T calculated. So we solve out our T calculated by plugging the data that we have to the formula. Now T calculated is equal to sample mean minus population mean over standard deviation square root of n, which is the number of observation. This now will give out T calculated is equal to 42 minus 46, 11.9 divided by square root of 12. The answer will be now T calculated is negative 1.64. Now from that step, now we come to another step whereby now we arrive to the statistical conclusion, whereby we compare our T calculated and our T test. We compare the T calculated and T tabulated, so as we can conclude where we reject or accept the null hypothesis. So from our obtained results, suppose now our T calculated is equal to negative 1.164, and our T tabulated that you obtain from reading the T table, whereby we are negative 1.796. So we compare now, since our T calculated is less than, our T tabulated, which is equal to 1.164 less than negative 1.796. Hence now we have enough statistical evidence. We have enough statistical measure to conclude that we accept a null hypothesis at the level of significance, which is equal to 0.05. So thank you for watching. This is DC Economics. Don't forget to subscribe my channel, and I welcome you to other session. Bye bye.